So, we are going to discuss conservation of momentum today. So, whenever we are talking about conservation of momentum, so because momentum is a vector quantity, okay?
Okay.
So, let us discuss it. Do you know what is the formula for momentum?
MV, right?
Yeah. So, momentum is P, we denoted by P, so it is mv. Okay. In Newton's second law, you already discussed that the resultant force is change in momentum divided by time. So that means it is a rate of change of momentum. Okay. So basically in this scenario, so we say conservation of momentum. Conservation of momentum. So conservation of momentum means momentum is always same for a body. Okay. Let
Yeah.
us say I am standing here. So I am having a momentum 0. Okay. And I am moving. So that means my momentum is changed
Because I have a velocity.
because I have applied a force. That's why my momentum is changed.
Is
Okay.
momentum just mass into velocity or is it mass into change in
No, no,
velocity?
no, no. It is mass into velocity.
Okay.
Okay. So for an example, it is also connected with the Newton's third law. There is an equal and opposite action of, there is an equal and opposite reaction of every action. Okay.
Okay.
So that is Newton's third law. So for an example, we say we have two bodies. Let us say this is your M1 body and it is going, it is just, we can say that it is in stable condition. That means it is not moving, its velocity is 0. Okay. And a body of mass M2 is coming from here with the velocity of V2. Okay. It is moving towards this body. Now, how was the momentum? It is getting collided with this body. So, how much was the momentum before collision? Before collision, how was the momentum? How much was the momentum? Its momentum was m2v2.
Yeah.
So, m2v2 and its momentum was 0, isn't it?
Yeah.
So, the total momentum becomes m2v2. And let us say after collision, both will move,
Yeah.
and let us say both are moving with the as a single body. So, if they are moving as a single body, so that becomes m1 plus m2, isn't it? And let us say it is moving with the velocity v. So, what is the momentum after collision? How much is the momentum after collision?
It will be M1 plus M2 into V.
m1 plus m2 into v. So, the question will be asked that a body is moving with the velocity so and so, its mass is so and so, another body is at rest or it is moving with that much of velocity. Now they collide with each other and find the final velocity of the two bodies. Okay, question will be like that. So that means by the law of conservation of momentum, your momentum before collision and momentum after collision will be equal. Okay. So that means it will be m2 v2 will be equal to m1 plus m2 into v. Okay.
Because momentum is being conserved.
Yeah. And let
But
us
how do
say,
you know? But
yeah,
how do you know momentum will be conserved?
momentum will always be conserved. That is the law.
Like, but provided that there is no friction or like any other external force, right?
Yes, yes, yes. That is an ideal situation. And if this velocity we can take it as v1, so that time your momentum will be m1 v1. Okay. So that time your m1 v1 plus m2 v2 equal to m1 plus m2 into v. Okay. They are going in horizontal direction. Vertical momentum also remains constant.
Why
Okay.
don't you just add their velocities as well?
Velocity is, we have taken momentum, the first body, momentum, the second body, just add it before collision. After collision, they are behaving like a single body. They are connected together. So if the single body is moving with capital V velocity, so that will be the momentum, and that momentum will be conserved. So we can put momentum before collision will be equal to momentum after collision.
Because
Okay.
I'm asking, because there's no other external force, why can't we just add their velocity? We can't do, why can't we just do v1 plus v2 to find their velocity?
No, it will not be, because masses masses are different. Okay. So basically we can add momentums before collision. That is the conservation of momentum law. Okay. So
I don't
moment,
understand because if there's no other external force, there'll be no loss in, there'll be no like loss in velocity. The acceleration will be same or like whatever it is. Why can't we just add the velocity one with velocity two?
because their masses are different. If you are 50 kg and some kid of 20 kg is pushing you, will you move anywhere?
No,
But if you are pushing that kid, what happens?
they will move.
So the scenarios are different.
Okay.
So you can't say that if this M2 is moving towards M1 and either M1 moving towards M2, the scenario will be same. It can't be.
Okay, this is because the mass of the object are different. Okay, so whenever if uh, if mass ball one is moving towards ball two, the mass of the balls are different. So when they are coming together, the first ball has to has to take the other ball with it. So that will add on its mass. That's its velocity will be different.
Yes,
The mass would be different for F is equal to ma.
yes, yes.
Okay, so the acceleration will change.
Yeah, acceleration will also be different.
Is because F is equal to ma and the masses will now change. So force divided by mass is equal to acceleration. So acceleration will change. And as acceleration is changing, the velocity will change. Okay, understood.
Okay.
Yeah.
So this was the situation in which both bodies are moving in the same direction. There
Yeah.
may be a situation that the bodies will be moving towards each other. Okay. So let us say that is body moving with v1 velocity, this body moving with v2 velocity, its mass is m2, it is moving in towards m1 and m1 is moving towards m2. Okay.
Yeah.
So in that scenario, what will happen?
The object, it depends upon the velocities and the mass of the object,
Yeah. But
in which
their
direction it will
their
be.
momentums are in opposite direction. So if you are taking this as positive, so this will be
Negative.
negative. Okay. As your momentum is a vector quantity, so once we add vectors, so that time uh, why we are taking it negative? Because they are in opposite direction.
Yeah.
Okay. So if we are adding these two momentums, so that will be that means it is to be subtracted. Okay. Got it?
Okay.
So
And
once
so, uh,
once we are talking about the momentum before collision, so that means the vector momentum before collision.
Okay.
Okay.
So will we take like I cap, J cap when solving it?
Yeah, we'll do questions, then you understand how to solve questions. Okay.
Okay. Momentum will still be conserved, right?
Yeah, it will be conserved. Before collision and after collision, they will be same. Got my point?
Okay.
Okay. So we'll do some questions, then you will understand how we can calculate. Yeah, this is a question.
Which one should I do?
A 30 kg shell is flying at 48 meter per second. When it explodes, explode means parts of that shell is moving. Okay.
Yeah.
So basically, initially it was of 30 kg. So let us say this is 30 kg shell. So a 30 kg shell is flying at 48 meter per second. It is flying it with the speed of 48 meter per second. When it explodes, its one part of 18 kg stops, while the remaining part flies on. Okay, that means it is just exploding into two parts. One is of 18 kg, another one is of 12 kg. The remaining will be 12. Understood?
Yeah.
So the 18 kg stops. So 18 kg stops means its velocity is 0, isn't it?
Yes.
And its velocity, let us say its velocity is v2. So just this is the picture. Just find out what was the momentum before explosion. So that will be equal to the momentum after explosion. Do you understand it?
Yes.
Aisha, are you enjoying the class? Sandeep Dhawal, Shayandeep. Rihan got the answer?
One second.
Everyone who is watching live, please solve the question and write the answer in chat box.
Done, sir.
Done?
Yeah.
What is the answer?
The answer is 120.
Yeah, 120 what?
120. Uh, it is kilogram into. Uh,
Kilogram
I
into
don't know
what?
the
It
unit.
is velocity here.
Oh, velocity meters per second. Sorry.
Meter per second. Good. Okay. Now do in the similar fashion you do example 20. Just do this 20th question. Example 20. Now you understood what is the meaning of law of conservation of momentum.
Yes.
Little bit.
Yeah.
Okay. As you do questions, you will be more confident in doing these questions. Okay.
Yeah.
Do it fast. We'll try to have one more topic.
I need to know something.
Done?
1 second. I'm just dividing. 3.3 into 10 power 7
3.3 into 10 to the power 7 and the unit?
meters per second.
Meters per second. Okay, very good. That's the right answer. Okay. Now try to do 21st. Are they simple?
Yes. This one, the calculation was a
Yeah,
like the one
it's
point. Yeah, the division was a bit big in this one. The 1.6 divided by 5.01. But like it was just directly applying the formula.
okay, okay. Doing 21st?
I need to draw the diagram for this first.
First of all, draw the diagram.
Baro?
Yeah. Okay, so 21st answer is 9 meter per second. Calculate faster, yaar, Vihan.
I'm still doing it, sir. Too many calculations in this one. So, the
Yes,
velocity, what's the velocity of the truck after the impact?
it is 9 meter per second.
After the impact.
Yeah.
Okay, 1 second. I think I got it. Yeah, 1 second. So, do you subtract the velocity of the car from the truck, or do you add them?
See, the car of mass 1000 kg traveling at 32 meter per second dashes into a rear of a truck of mass moving in the same direction. Actually, they are moving in the same direction. So, before collision, your momentum has to be added because they are going in the same
No, no,
direction.
after collision, after collision.
After collision also, they will be moving in the same direction.
If you add them, then you get 8 is equal to 1 plus x after simplification, which comes out to
See,
be 7.
before collision, this was your car and this was your truck. This was truck and this was car. So you have to add their momentum because they are moving in the same direction. If they are moving in the same direction, so momentum is to be added. And
So I think
after
after collision, I think you need to subtract it. You cannot add them because it's bouncing
why
back. And if you add them, then the answer is coming out to be 7. But if
they
you add them, but if you subtract them, then it comes out to be 9. The answer which you said.
see they will be moving in the same direction after impact.
No,
Okay.
sir. It bounces back.
No, 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 it will not be bouncing here. Why it will be
No, so
bouncing?
they said that in the question. After the collision, the car bounces with a velocity.
Bounces means it will not bouncing back. If the truck is impacting it from behind, how it can be bouncing back? It will be going in the same direction. Okay. So after collision, the car and truck will be moving in the same direction, isn't
So
it?
you try it. It's not. Then it comes out to be 7 if you add them. You need to subtract them. That's the only way it comes out to be 9.
No, 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 no. You need not to be subtracted. Okay, okay. Sorry, sorry, sorry.
Exactly, because if
Sorry,
you
sorry,
add them,
sorry.
then it comes out to be 7. You need
Yeah,
to
yeah, yeah.
subtract
Sorry,
it.
sorry, sorry. So car bounces. Yeah, it is given car bounces with a velocity of 8 meter per second. So that means velocity is to be taken as negative. Okay. So the
Yes.
velocity of car, that means momentum of the car will be negative, isn't it?
Yeah. Yes, so which question do I need to do now?
Okay, now it is the time to do 20 second. 20 seconds of the question. And my live YouTubers, I'm checking your comments also. Okay. Okay, Vihan, just do 20 second. And there is so much background noise here. What's happening?
It should be gone now.
Okay, okay. Thank you. My live YouTubers are faster than you are. They're asking to scroll up. Go faster.
How do you do question number 22?
22. A hunter has a machine gun that can fire 50-gram bullets with a velocity. So it's a gun and bullet. Okay. Bullet's mass is 50 gram with a velocity of 150 meter per second. A 60 kg tiger springs at him with a velocity of 10 meter per second. How many bullets must the hunter fire into the tiger in order to stop him in track? So first of all, you have to find magnitude of the momentum of the bullet. Okay. And you find momentum of the tiger.
Yeah.
So momentum of one bullet, how much it will be? And that should be equal. If you want to stop the tiger, so your momentum must be equal. Okay.
Yeah.
But how many bullets you need to fire? So let us say momentum of one bullet is mv and momentum of n number of bullet is nmv. That will be equal to momentum of the tiger.
But so, but wouldn't a bullet pierce the tiger because of its pressure? Then how can it stop the tiger? The area of the isn't the
If
area of the bullet too small to stop the
see
tiger?
if a body is coming from here, a body is coming in this direction, so they will stop each other if their momentum are same. Okay?
Okay, then it's easy. Then I can solve it. Okay,
Okay.
I see.
So you just find the momentum of one bullet and keep it equal to the momentum of the tiger. So that n will give you the number of bullets. Okay?
Yeah.
Okay. So we are just scrolling it up. Just do it after the class. So now try to do 23rd question. It's very important. It is asked in IIT 82. Before JEE it was IIT. I'm giving you some hint in 23rd question. You just have to use your vector ability in this question. Okay.
Okay.
Sandeep, are you doing 23rd question? Okay, just I'll give you a little bit of hint. A body of mass 1 kg is initially at rest. Now it is exploding into 3 fragments of masses in the ratio 1, 1 and 3. Okay. So earlier it was a body of 1 kg. So 2 pieces are going perpendicular to each other. Okay.
Yeah.
And other is the heavier one, let us say it is moving like this. Got my point?
Yeah.
So this entire, the angle between these two masses is 90 degree.
Yeah.
So we can say like it is going horizontal is this one, so that will be 45 degree, that will also be 45 degree. Let us say this is mass and they are, it was initially 1 kg and it is fragmented into 1:1:3. Okay. So what will be the mass of this body?
So it will be M1.
Hmm?
Okay, so because you need to divide it, you need to divide it by is 1 kg, right? So it will be 1 into 1 by 4. So it will be 0.25 kg.
Yeah, so that will be 250 gram. 250 gram. It should also be 250 gram and that would be 500 gram. Isn't it? Are we doing some mistake?
No, yes, sir. It should be divided by 5, not 4. Need to do 1 into 1 by 5. That's what you need to do.
1 by 5 into 1. So that means
Yeah,
200, 200.
exactly. Yeah.
200, 200. Okay. So that will be 200 gram. That will also be 200 gram. And that will be 600 gram. Okay.
Yes.
So you just need to find out the momentum, because this mass, this body is moving in this direction. So before explode and after explode, just find out the momentum and keep them equal.
Done.
How much you getting?
I'm getting exactly 20.
20 meter per second.
Yes.
Okay. Okay. So before explosion, how much momentum it was having?
0.
0. And after explosion, its momentum, see, this is its horizontal momentum. So if it is 45 degree, so that will be uh, 200 gram, we can write it 0.2. Okay. And what will be the horizontal component of velocity?
Horizontal component. It will be uh, velocity into cos 45.
45. Okay. So velocity is 30 meter per second.
Yes, it will be 30 into cos 45.
So that will be 30 into cos 45. The same component will be having this body, the same
Yeah.
thing. Okay. So that will also be 0.2 into 30 into cos 45. Okay. Now this third body is moving in opposite direction. Okay. So what will be its momentum? Its momentum will be negative of mass, that means 0.6 into the velocity. Let us say the velocity of this body is v. Okay. So if we take this negative to this side of equation, so then your v would be, it will be twice of 0.2 into 30 into cos 45. Cos 45 is 1 by root 2, and it will be divided by 0.6. So 2 3s are 6, 3 10 30. So that will be 2 into 10 divided by root 2. Okay. So that will be exactly 14.14 meter per second. So 20 by root 2 is 1.414. So that exactly will be equal to 14.14. Okay.
So, but why did you take only the horizontal component?
Because we are just talking about the horizontal momentum,
How do you know that?
because this, if we can go with the vertical momentum also, vertical momentum component will also be in conservation.
No, but why did you only take one component? Why didn't you take the entire move? Why didn't you just take them? Why did you like
Because
break it into its component?
because horizontal component is solving our problem. That's why we have taken horizontal component only.
Why is it solving it? How do you know that it's solving it?
Either you take horizontal component or you take vertical component. That is not an issue. Okay. But in
But why can't
this,
we just take them? Why are we breaking it into its component?
because it is going in the different direction, they are not going in the same direction. So that's why the components will be into the picture. Okay.
Okay.
Once they are not going horizontally, then you will have to take components, because if you are talking about momentum, so it will be having two components, horizontal and vertical. So
Okay.
both horizontal and vertical will vertical momentum will be conserved differently. Horizontal with the horizontal one, vertical with the vertical way. Okay,
Okay.
got it now?
Okay.
Okay, so now just try to do 24. Getting it now?
Yes.
How much will be the change of momentum? Change of momentum of each marble.
1 second, sir.
It is going with velocity v.
Yeah.
It is going with velocity v. Coming with velocity v. It is rebounding it.
Yeah.
So what will be the change in momentum?
Nothing. Zero.
Momentum is in different direction.
Yeah, it will.
So it will be
But the
added.
mass into velocity would. But the mass
Init-
into velocity would be the same. That's the problem I was facing, right? The mass, the
initially,
mv upward to mv downward would be same.
change in momentum means what? Initially it was going with the momentum mv.
Yeah.
It is coming with negative mv.
Yeah.
So how much is the change?
Okay, so it will
Minus,
be MV minus. Okay, it will be 2 MV.
yeah.
Okay.
So that will be the change in momentum per second. Okay. And change in momentum per second, how much it is? Change in momentum per second. What is that? It is
That's
the
force.
force. And in this case, force is,
0.
why it is 0? It is
Mm.
the weight of disk.
But like there's no acceleration, so.
It is the weight of disk.
But there's no acceleration,
How
so.
much force they are applying?
The force would be mass into acceleration, right?
But disk is not moving anywhere.
No, exactly. It's not moving anywhere. So
So the
there'd be
only
no
force,
acceleration. So mass.
so the only force will be mg. Okay.
Yes.
So that will be equal to
10G.
mg. So if you write, just try to solve it. Now you will find your answer. How much velocity? And how many bullets, how many discs are there? How many marbles are there?
10. So multiplied by 10.
Yeah. So that will be 20 mv.
Yes.
So 20 mv will be the rate of change of momentum per second.
Yes.
Got the point?
Yeah.
Okay. So this is the exercise for the conservation of momentum. Just try to solve it. I have sent you that exercise also. Okay. So this question is for your homework. Okay.
Okay.
So you need to complete all these questions and just send me the PDF.
Yeah.
So if you have any doubt, we'll discuss it tomorrow. Okay.
Okay.
Tomorrow I think 2 p.m. is fine to have a class.
Yes.
Yeah. So
No, I'm free.
yeah. So for 2 p.m. we'll be having class tomorrow. Okay.
Okay. Thank
Okay
you.
then. Bye bye. See you.
Bye.